Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about introduction to functions. Previous classes we clearly discussed about relations. Please watch those classes and come back here. This is a continuation class. The link for the playlist is provided in the description below. Coming to today's class, so let x and y be any two sets. You take any two sets, let x and y be any two sets. A relation f from x to y is called a function. So before you check for function, it should be a relation. What's relation means? It is having ordered pairs. Means x, A relates B, A relates C. This is what we discussed previously about relations. We are having ordered pairs. So a relation f from x to y is called a function. So when we are going to say it as a function, it has to satisfy this condition. If for every x belongs to x, there is a unique y belongs to y. If it satisfies this condition, then we say it as a function. So remember this properly. You are going to understand this condition with an example very easily. Just remember this condition. If for every x belongs to x, so 2 points you have to remember. For every x belongs to x, there is a unique y belongs to y. So with example, we are going to understand this. Let's take an example. X is a set, y is a set. X set contains 1 to 5 elements and y set contains y1, y2, y8. So these are the elements which we have in this set, and we are having a relation y1, y2, 2, y1, 5, y2. So this is how we show it in the functions. 1 is related with y2, 2 is related with y1, 5 is related with y2. Can we call this as a function? Yes, we can call this as a function. So why we are going to call this as a function? It is satisfying this property, this condition. For every x belongs to x, for every element x belongs to x, there must be a unique y belongs to y. Means if you take 1, for every x belongs to x, 1 is an element that belongs to x, 1 is mapped with y2. So 1 is having a unique mapping in y, which is y2. Similarly, if you take 2 is having unique mapping in y, which is y1, 2, y1. Similarly, if you take the third one, 5 is having unique mapping with y, which is y2. 5 is mapped with y2. So that's why we can call this as a function. For every x belongs to x, there must be a unique mapping with y. Unique y belongs to y. We can call this as a function. So let's take an example for better understanding, which is not a function. If you take this example, x and y, this is how the mappings are. 1, y1, 2, y1, 1, y2, 5, y8. See here, if you take the x belongs to, for every x belongs to x, 1, it should have a unique mapping, but here 1 is mapped with y1, 1 is mapped with y2. It is having two mappings in y. This is not accepted in function. It is not a function. That is what this statement says. For every x belongs to x, there is a unique y belongs to y. Mathematically, this statement can be shown as, uniqueness can be shown as, for every x belongs to x, there is a unique y belongs to y. This can be shown as, if you take the ordered pairs that belongs to this function, x comma y belongs to function and x comma z belongs to function, then definitely y is equal to z. X comma y, x comma z. If these two belongs to function, then definitely y is equal to z. Then only it is having unique mapping. Otherwise, it is not having unique mapping. See here, x means 1, y means y1. 1, y1. X means 1, y means y2. 1, y2. If this happens, then y1 is equal to y2. No, it is not equal. It is not same. That's why it is not a function. For better understanding, one more example. Let's take the next example, x, y. This is how the mappings are. 1 is mapped with y1, 2 is mapped with y1, 5 there is no mapping. Can we call this as a function? No. What's our statement says? For every x belongs to x. Here this is not having a mapping, so we cannot call this as a function. Each and every element here in the x should have a unique mapping with y. That is what that statement says. It is not a function. So this is what the definition of function. Now we are going to understand few more definitions. Functions may be known as, the other name for function means mapping, transformation, correspondence and operations. But most of the times we are going to use mapping. Function, mapping, interchangeably we are going to use this word. Now the remaining definitions which we are going to understand. Let's take this function x, y. 1 relates with y1, 2 relates with y1, 5 relates with y2. In this, domain of a function means whatever the elements that belongs to x, we call it as a domain. 1, 2, 5 is the domain of this function x tends to y. Similarly, codomain means whatever the elements that belongs to y, we call it as codomain. y1, y2, y8. And the next definition is range of a function. Whatever the elements that are mapped in y, means y1 is mapped with some other element in x, y2 is mapped with some element in x. Whatever the elements that are mapped, those elements we call it as a range of the function. Means y1, y2 is the range of the function. Domain, codomain, range of the function. Now the other way we are going to show functions is, not only this way we can show functions like this. Y is equal to f of x is equal to x square plus 1. On the relations, on the mapping R tends to R relation with R. Here R means set of all real numbers. Set of all real numbers mapped with set of all real numbers. How it is going to map? Y is equal to f of x is equal to x square plus 2. Let's take an example. If you take x is equal to 1, you can take any element from real numbers, minus infinite to plus infinite. If x is equal to 1, substitute here 1 square plus 2, y is equal to 3. So 1 comma 3 is an ordered pair in our relation. This is how we are going to show functions. This is the other way we are going to show functions. Hope you understand what functions means. So if you don't understand this, we are going to do multiple examples in our next classes. So how we are going to write these equations. Hope you understand the definition of function and different definitions for domain, codomain and range. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.